Hello and welcome back. Today I have three handheld LCR meters. It is the Hantek 1832C. It is the DE5000, very popular, exists for 10 years at least I think. I have an EastTester, the ET432, and I like to compare those against the basic model and LCR meter for desktop. This is the Victor Rosui 4090C, which is equivalent to the ET4410 from EastTester, and I also like to compare it against the Precision, the GW-Istek LCR 6002. Let's start with the Hantek. This is the 1832, but there is also an 1833 model that has a higher frequency. Nice color display. All kinds of different auto modes, different voltages, different frequency. I will get the specifications later. This one is the DE5000, very popular, good reputation, more simple display. And here we have the latest from EastTester, the ET432, nice color display. Looks very similar to the Rosui display here. Also auto mode, different voltages, different frequencies. This one is a little bit higher precision. It is a desktop model, but of course it's more expensive than the handheld. So let's see if that is worth it. So I like to compare it with it. And all of them will be compared here with a high precision, lots of digits from GW-Istek. What I like to do, I have here my DMN Check Plus, and I have some resistors, I have some capacitors, and all these values have been verified against 3458A, that's a 8.5 multimeter, and the PK891 LCR meter. Let's talk about prices, capabilities and accuracy, so we know what we're actually comparing, starting with the Hantek. The Hantek is the cheapest here for $125. I checked the prices in AliExpress and Google, and this is what we pay here in the Netherlands, so it includes the VAT. Is up to 40k, it has two voltages, has an auto mode, basic accuracy is like 0.25, it has an open short calibration, and it has 40,000 counts. It has kind of a rubbery feel, but it is all integrated so you cannot take it out. It runs on these 18650s, two of them. You probably run them for at least 6-8 hours, I would expect, because of the color display. If your eyes are not that good, sometimes it is a bit difficult to read because they have here white and green. All the other fonts are quite big, which is good. The control is very intuitive. If you have your frequency, it is here, you have your range here, you have your level here, and it is kind of at the same place as the display, so that is good to find. So the Hantek only comes with this and with the 2-wire, but I like to do the measurements with the Kelvin, so I bought this one separately. If we go one step up, then we come into the EastTester. Can go up to 100k, has a lot of different voltages to set. Auto mode, we see here that accuracy is better, 0.2, open short calibration, also 40,000 counts, but we are already close to 180 euros. The EastTester looks a little bit more modern, also has this rubbery feel on the outside. You can take it out and then you have kind of the same plastic as you have with there, so it kind of looks a little bit cheaper, but with the cover it protects it from falling. It has its own battery pack. It's a little bit smaller than this, it is just in here, but you can charge it here with USB. It is still the older USB, not USB-C, and you can communicate also through this port with the computer, but it doesn't have specific software. It is just SAPI compatible. Comes in a normal box, manual, but we do get a nice Kelvins that we will be using, and USB cable, and also just like the Hantek with these. But then we go to the DE5000, 100k. 0.5 volt only, auto mode, basic accuracy open close calibration, it only has 20,000 counts and you pay around 195, but you get a lot of accessories with it. Even though it's good reputation, it kind of feels very light, and the plastic is not necessarily seems high quality, but I have seen in the comments many people that say have it more than 10 years. It just runs on a 9-volt battery that seems a bit light, but because they use the standard LCD, you can probably run it for many hours. The display is very easy to read, all the buttons also with the big fonts, so it's all very organized. Also, there is an option that you can run special software. I think there is an infrared here in the bottom, so you click it on and then it can be communicating with the computer. The DE comes in a very nice box with suitcase and it has a lot of accessories. So for this 195 you get a lot of stuff, and it comes with its own clips. Here we have a tweezers, here we have sort of 2-wire, it's a pity it doesn't have proper 4-wire by the way, like with Kelvins. And I had a better look at these clips, and these could be 4-wire instead of I said that it would maybe be only one. It's kind of shielded cables. The cables could have been a little bit longer to be honest, but it probably will function very good. The Hantek and the EastTester use this type of Kelvin clips, which you can see here can lock because it just goes easily in and out, but if you slide it to the right it should be locking. Well, it's sort of. What I like from the DE is that they use also the normal terminals. It is just plastic, but it gives it an extra grip, so when you fix it, it is really stuck and it doesn't move. So that's a real good thing. I like to compare that to the desktop model, the Victor or Osui, the ET432. The desktop model here has all BNCs and it comes with these cheaper Kelvins with BNC, nicely double shielded, but you probably get better results if you use a real fixture. 100K, a lot of different voltages, auto mode, and the accuracy is here a lot better, so it's at least twice as good. Open short calibration, 40,000 counts, but then we are already close to 300 euros. Then we go at the GW-Istek, the high precision. It goes up to 2K this model, and we have a lot of voltages between 0.01 all the way up to 2 volts. It does have auto mode. The basic accuracy is a lot better, 0.05. It has open short calibration, but also full frequency range. It has 1,000,000 counts, but of course we pay a lot more. It's 1150. It's also with 4 BNCs. I'm using here a real fixture. All shielded cables here and with higher quality Kelvins, so we should get very good results here. Knowing that I'm not a very advanced user of the LCR meter, I want to start in auto mode, and my experience with the LCR tweezers that I did videos on, it's best to start just on 1 kHz, 0.5, 0.6 volts, and then we can later see if we adjust the frequency, if we can get a better result or not. And about that maximum frequency, you see here, this one is up to 40K, this one is up to 100K, but the higher precision here only goes to 2K. So does it always mean that a higher frequency gives you a better accuracy? Well, apparently not, but I could imagine if you have very low capacity or very low inductance, that it might be very helpful to be able to run it on a higher frequency. But let's just do our tests. Before I start doing measurement with each of these LCR meters, I will run them through their own calibration procedure, which is the open close one. Okay, I run it through the calibration. Let's first do the resistors. I can enlarge the display a little bit. It says 100.002, 003. It's mostly 003. Just to check our baseline, the measurements that DMM Check Plus did on their meters here, does that properly compare to our measurements that we did with a high precision LCR meter? And I would say they agree almost on the digit. Little difference here when it becomes a little bit bigger, but most of them are exactly the same. So this is a good baseline. Let's start. Let's start with the open-close procedure. It is in auto mode, 1K, 600 millivolts. The speed is slow. That is okay because you get the highest accuracy. And it is now in parallel mode, so just leave it as it is. I think we need to push along the, yeah, it says insert the shorting. Well, we are not using the components directly, so I will short the connections like this, and we push the rail again. That was calibration for resistance, so let's just measure our resistors. Let's do the caps. It automatically detected CP mode. That has to do with the parallel mode or serial mode. And it depends if it is a big or small capacitor, if that changes, but it doesn't change much. So this is a good value. Well, here I found something about the serial and parallel mode. It has to do with the internal measurement circuit. So if you have large capacitor, it's better to use the series mode and a small inductor. And if you have a small capacitor, it's better to do it in parallel, or when you have a large inductor. Well, now I want to measure inductance, so we have little coils here, and I doubt that is possible in auto mode on the simple fact, of course, that it is almost a resistor or a short. So probably when we do this, it will not find out what it is. It will just think, oh, it is a resistor. Let's just give you an impedance, and maybe there is a little phase shift. We can see that. So I probably need to switch it here, manual to telling it is inductance. And we see this jumping a lot. And what if we set it now to, okay, I set it now to parallel mode, and when we change the frequency, you see the value keep changing. So then we sort of know, okay, parallel mode for this coil is not good because it's jumping around. So then we put it to serial mode, and now it is 1 microhenry. If we change the frequency now, it is still 1. Change more frequency, look, now it is still 1. So then we know, okay, we need to use serial mode, because in the serial mode on any frequency it gives the correct value. Let's go back to the most digits. That would be this one. This is also a good example to see that the 40 kilohertz now is very useful, because it gives us now an extra digit. Then we have the there. It doesn't have kelvins, but it has these tweezers, but it could work just as fine, of course. So we put it in, it is in auto mode. Let's do the calibration. I think it is a very long push. Here it is, the open calibration, and we wait. Yeah, here we also see that the 100K gives us a lot more digits when we compare, like here. And also the value comes a lot more close to the original value that we have here. So the higher frequency is indeed a good option. When we have a look at all the results, when we check the resistance, the calibrated values and the high precision desktop meter are totally in agreement. We can see that Hantek and the EastTester are also very close, and we see a slight change here in the DER and the desktop model here. When we look at the capacity, they all seem to agree very well on the lower frequency as on the higher frequency. Sometimes we get a little higher accuracy on the higher frequencies, but I found something else. When the value becomes higher, it seems that we need to measure with a lower frequency, because here it says it is 1.036. I measure here 105. And on 2K 105, here also 105, 105, 105, 105. When we look on inductance, we sort of see the same. They all agree there is no real bad meter here. And we see when the frequency becomes higher on the DER, we see here that we get some extra digits. We see the same here also. But again, when we go to the higher values, we have here 1.024. I measure 104, 104, 104, 104, 104. So what happens with this calibrated value here? Well, it is done with the BK891, and we saw in the higher frequency we get more accuracy. But that is of course until a certain value, and this one goes up to 300k. I can't find in the documentation which frequency they use to measure these upper values. Then I found documentation of the BK891, and we are here in the line of the 1 microfarad and the 1 milliari, exactly what we measured here. And when we look at the frequency, here we have the 1k line. If we go above 1k, the accuracy, which is here 0.05, we go immediately to 0.02. So, because if we go above, well, we can see what happens here. And even at 100k, we are already at 1%. So if they did that on 300, we are probably somewhere here, and then you are in 2%. So that really means we need to stay around this 1k. So what it seems so far, small values, you can use higher frequency for higher accuracy, but while the values become slowly higher for your capacitors and your inductance, you need to start to use lower frequency. I don't think all these handhelds have these special tables, but it is kind of a rule of thumb. And we will see that also on the electrolytics. We need to measure on 100 Hz or 120 Hz because they are made for those frequencies. So what I like to do now is also measure electrolytics and tantalums, and then we can write down also the ESR, the D, the Q, and the phase shift. I have 470 microfarad, 1000, 7400 on the electrolytics, and I have a 2,2 micro for tantalum, and I have a 1 microfarad for tantalum. And I like to see also if I measure with different frequencies. I start with 100, then I do 1k, and then I do the maximum, I think it's 10k. All the meters I have run again through their open close calibration. I will start writing down values and let you know the result. So that was 2 or 3 hours of good fun, changing caps, changing frequency, changing secondary measure mode. I did that on all 5 meters, and I must say the 300 are pretty user friendly. Also the Victor that I used as my secondary reference, this one is also very user friendly. The GW-Istek, not so much. It is more made with putting once the frequency and then just change the modes. But if we look at these three, very equally matched. What about the values? Well, the values that they measure were also pretty equally matched. Only I found a few exceptions. It is all very equally matched. I don't see really things that really stand out. The only thing is that on the lower frequency, the DER sometimes just doesn't give you that extra digit for the ESR. and I see that here, I see that here, and I see that here. But later on the higher frequencies, this is all on the 100 Hz. But when you go higher, like 1K, you do get that extra digit, but the others still have one more. And when you start to do silly stuff like putting 1 kilohertz on a 7400 microfarads, then no one gets a proper measurement except for the EastTester here and the desktop model. They do get measurements. So that one stood out here. The other ones just totally give up. Here I didn't have any measurements at all. This is a 10K, which is of course silly, but I did get some sort of values from the desktop model also here. 100 Hz on 1000 microfarads, all the values are very similar. Then when we put 1K on the same 1000 microfarads, we could see that actually there was closest by to the reference. And then I put 10K, and then I didn't get any measurements, only from the tabletop model. The tantalum do a lot better on higher frequencies than the Releted. Again, the values, not too much excitement in between them, except again, when you start to go to higher frequencies, here 10 kilohertz, then there again was closest by to the reference, the tabletop model, and here also with the 2.2 microfarads, also there was the closest by. So all three handheld LCR meters are pretty good. On the smaller values or on the lower frequency, I can't see much difference between them. Only on the secondary measurement, the ESR, on the lower frequency, there sometimes gives you less digits, and the other do give you the extra 1 or 2 digits. When we push them to the limits, we work on the edge of the possibilities. The fight is between the EastTester and between the DE. What we have seen on higher frequency, on a little bit bigger capacities, the DE really gives the best result between these. Price range again, 125, 180, 195. This is 4 years old, and also sometimes it's hard to read with the green and white. Lower frequencies, they all work fine, no problems there. When you try to push them and you try to do big capacitors on a higher frequency, these and these are very equally matched, but in the end this one is the winner. It must be very difficult to choose between these two, because the DE has a very good reputation. It is more than 10 years on the market, and the people that have it are crazy about it, and it still works after so many years. This one looks a little bit more fancy, more modern, the nice color display, easy to read. This one does have a backlight, but still this is a much better to read. So it would be very difficult. Do you go for the modern, or do you go for the good reputation and good product? So that was it, my big LCR test. I did a lot of measurements. If you're interested in the results, I will put it in one big zip file. Also maybe the table with the frequencies and what capacities or inductance is best to use on your meter. This one is from the DK, but probably it is sort of a rule of thumb when you need to switch back or switch up to a frequency. All the information I have, I will put down in the links. Thank you for watching, and I hope to see you next time.